Hello and welcome to this episode of Microchips, and on the bench today we have another CB Master 3600 that come from that famous container that was found. This one's actually faulty, surprise surprise, so we're going to fix the faults, get it all up to standard, and then we're going to fit one of my LED channel boards to it. But before we start, don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website, microchips.net. And let's get started. So, lifting the lid off, as to be expected with one of these radios. Everything is pretty much as it left the factory. No horror stories in there, everything looks intact, no parts missing, no signs of anything that's been butchered. So yeah, having a look at the printed board side, and there's no horror stories here either. No cut tracks around the PLL, which we like to see, and everything looks just fine. So let's fire it up and see what happens. So, that's to be expected. No transmit, no receive. Let's do some fault finding. So we're on the VCO test point, monitoring the VCO voltage, and it's stuck on 1.1 volts. So do we have a VCO failure or do we have a PLL failure? Well, it's going to be one of those. That PLL core, VCO core is very stiff, so we won't bother turning that. So we're just having a look at the 10240 crystal, make sure that's oscillating correctly, and yes, we have a 10240 signal, so there's no problem with that. Everything looks just fine there. So we're having a look at the mixer crystals, and they're working just nicely. So that's not our problem. So the first easiest part to change will be the VCO. The VCO is going to get replaced anyway. We're going to fit one of my voltage feed VCOs to this, so it's going to come out anyway, whether it is faulty or it's not faulty. So we'll just use the desoldering gun and we'll get the VCO out. Just like so. And this is what we're going to be fitting, one of my voltage feed VCOs. So let's solder this in place. And for all you wondering why I'm using this Zoe soldering iron, I've actually getting quite fond of this soldering iron now, with its ease of changing the tips. So we'll solder on the supply to the VCO just to this point here, which will be our regulated 9-volt supply from our AVR, and we'll switch it on. And now we have 0 volts on the VCO. So it's looking like our PLL is at fault. If you're thinking that I've not adjusted the VCO, I test every one of these VCOs when I make them, so they should just plug in and work with minimal adjustment required. So let's take the PLL out. So there it is, our PLL that we're going to replace, and we'll put in another one. And we'll get that soldered in. We'll switch the radio on, and now we have 4.5 volts on the VCO, and the voltage is changing when we change the channel. So it looks like our PLL was at fault with this. Again, seems that all these ones that were faulty seem to have PLL failures. We'll just lower the VCO voltage down just a tiny little bit, so we've got a good voltage across all the bands, which we have. Very nice. So I've taken the front off, and we're going to do the usual performance modifications, which will be R44, the 33 ohm in front of the pre, and the audio limiter, which will be R150. So we're going to change those to start off with. So we'll pull out the audio limiter, changing that to a 5.6K. R44 already fell out. We're going to be changing that to a 15 ohm, and we're going to be changing that one to a 33 ohm. So we'll solder these back into place. That will sort out the biasing for the pre and the final drive. And we'll solder the audio limiter just like so. And let's have a look at the bias voltage. So we'll adjust that for around about 0.7 of a volt. And there it is. That'll do. And we're just going to have a look at the pre-drive bias. We'll just transmit 0.75. Yep, good enough. Nice bias voltages on there. So we should be driving the transistors correctly. Now we're going to be changing C99, C160 and C162. C99 will give us a bit better SSB bandwidth for the receive, and 160 and 162 will improve our transmitted audio. So we'll take those out. C99, we're going to replace that with 100 picofarad. 160 and 162, we're going to be putting 47 nanofarads in. So we'll solder those up, and we'll clip the leads off. And there we go. That's our capacitors in place. Very nice. So next modification we're going to do is we're going to replace the AVR regulator with a 9 volt linear regulator to make the 9 volt supply inside the radio nice and stable. So we're taking out the cap, we've taken out the AVR regulator, and we're going to be replacing it with a 7809, which should just bolt around here nicely. So there it is, roughly in place. And we'll solder the wires in, and we'll check the input and output. As you can see, we've got 8.9 volts, 13 volts going in. Yeah, very nice. That'll do just nicely. So there's our regulator fitted, nicely bolted to the side for good heat dissipation. So just having a look at the frequencies, everything's a little bit low, but it's fine. Having a look at the 10692 and 10695s, they need a little bit of adjustment, but we can sort that out. So it's not too far out. So we've adjusted the 692 and 695 for our SSB carriers. Now we're going to put an unlocked clarifier in this. Now I always like to change these to a linear pot, so it gives a nice smooth shift, and it's not twitchy around the edges, should we say, because the pot that's in there is a logarithmic pot. I always find that putting a linear pot in gives it a nice even shift across the range of the pot. So we're going to replace it. We're going to solder its original wires back on. So one of them's the ground wire, and one of them's the wire that actually goes off to the vari cap. As you saw before, we've pulled out a diode and a resistor, so that stops it from only being active on receive. And because we've done that, we need to add voltage to this pot. So we're going to add an extra wire, and that will go off to our 9-volt supply, which will go just there. And that will give us an unlocked clarifier. Now it doesn't go too far, only getting about 3 kcs either side, but that's more than enough for this. So we're going to fit one of my LED channel boards in there, a filter board and a PLL adapter board, and that will then give us our 5 kcs alpha channels and mid-high in UK40. So for this operation we need to start removing wires, so we're not going to be needing any of these wires, but those 3 go off to the band switch. We need to take out the PLL that we've previously fitted, because we're going to be fitting this onto its own daughter board, and we need to unsolder the actual channel change itself, which is always a little bit interesting to get out, but just releasing the 2 front screws and we can get that out of the way. And there's 1 screw down there, and then there's 1 brass standoff that we need to remove, just like so, and out comes the original display board. So we've fitted a couple of smaller brass standoffs there just to support the new board, and there it is in place, all looking very good. We've also added a couple of an extra hole and moved the crystal board along so we can fit our filter board for the supply for the new front board. So with the PLL removed, we slot it into our daughter board, connect the wiring up, and then we can put this back into the radio with no ugly cut tracks. Yeah, so that's our PLL daughter board fitted. We'll solder all this back in. Just like so. Now, because these band switches aren't being used anymore, we can pull them out and find out where the mid-band wire is, so that will be the green wire. Now we need to find a positive USB and LSB. Now on this radio there is actually one set of poles that are spare, and it's only used for LSB, which will be the brown wire. So we're going to use 2 diodes, just like so, and that will give us our SSB sensing for the front board, so it can switch in 5kc. So that's standard AM/FM operation. Switch it over to sideband, and now we have the dot, which denotes that we are on a 0 channel, and the other dot denotes that we're on the alpha channel. And because the shift isn't powerful enough on this one, we've used one of my frequency compensation boards on the back of the crystal. So there we have everything installed that's going to be installed. So I suppose we should do a final alignment on it. So the main crystals are off a little bit. I'm seeing it's only got one crystal in it. It should be easy enough to align, and all the other bands should follow that, as we've only got one crystal. So using our scope, we are going to have a look at the SSB carrier balance, and sure enough it was out just a little bit. So quick adjustment of that sorts that out. It's amazing that these radios ever worked when they come out of the factory. And now we'll have a look at the FM demodulator. Just make sure that this is peaked and working correctly, and it looks like it is. So no further adjustment required with that. And of course, everybody's favourite part of the video, the synad readings. So it's got good ears on it, not too bad at all. Listening down to minus 115 dB. So yeah, that's nice. We'll drop it down to channel 1 mid-band. And again, it's working just nicely down there. So let's move up to channel 40 UK FM. And I can't seem to get any reading on the synad meter. Interesting. And it's not moving at all. So putting the voltage meter onto the VCO test point, I found out I've not set the VCO for the top end of UK40. So as soon as we adjust the VCO a tiny little bit and we get the radio into lock, the synad meter shows us that we're working. Put it back down onto channel 40 again, and there we go. Very nice. So there's our CB Master 3600 with its different PLL modification. And it's working quite nicely. So I hope you enjoyed this video. Don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website, microchips.net. Thanks for watching, and we'll see you in the next episode.